Good morning, dear students. Today we are going to discuss about your internal combustion engine, or otherwise known as your IC engine. Before we come to the topic of internal combustion engine, we will discuss first about your engine, or what is a engine or what is a heat engine. Okay. So heat engine is a device which transforms the chemical energy of the fuel into thermal energy or heat energy, and again this heat energy is converted into your mechanical work. Okay, so a heat engine is a device which convert but transform your chemical energy into some mechanical work. Examples of the heat engine are your thermal power plant or thermal power station and internal combustion engine. We are going to discuss briefly about your internal combustion engine in this video lecture. Okay, so first, classification of heat engine. What is the classification of heat engine? The heat engine is classified into two types. First is your external combustion engine, and second one is your internal combustion engine. So what is the external combustion engine? The name indicates that the combustion takes place externally. Okay. So what is the definition says that the external combustion engine are those in which the combustion takes place outside the engine. Okay. The products of combustion of the air and fuel transfer the heat to a second fluid, which is the working fluid of the cycle. So in your external combustion engine, the combustion takes place outside the cylinder, not inside the cylinder. Okay, and due to the combustion product, by using the combustion product, we again heat the second fluid, which is working as a working fluid, or the fluid which is used to deliver the heat. Okay. But in case of your internal combustion engine, the air fuel mixture or the combustion of air fuel mixture takes place inside the cylinder. Okay. So example of your internal combustion engine is your petrol engine or diesel engine. Or example of your external combustion engine is the steam engine. Okay. Again, next slide. What are the limitation of your external combustion engine? Okay, so first, a steam engine, which is an example of an external combustion engine, is a heavy engine due to the presence of boiler and furnace. Due to the presence of boiler and furnace, the external combustion engine is a heavy engine. Okay. Next point, it operates on low efficiency. External combustion engine has a low efficiency, that is up to 20% efficiency. Only 20% efficiency an external combustion engine can give us. Third point is the steam engines are unsafe because of the presence of boiler, okay, which can burst due to excess of steam pressure. A steam engine, which is an external combustion engine, is unsafe because of the presence of boiler. Okay. Fourth point is, due to this limitation, the external combustion engine by EC engines are replaced by your IC engine. Due to this limitation, your external combustion engine is replaced by your IC engine, which is known as your internal combustion engine. So here we will discuss about the classification of your internal combustion engine according to the types of ignition and according to the fuel use, according to the number of stroke. In these three parameters, we are classified the internal combustion engine. First, according to the types of ignition, your internal combustion engine is classified into spark ignition engine and compression ignition engine. Okay. Second, according to the fuel used, your internal combustion engine is classified into your petrol engine, diesel engine and gas engine. Third one is according to the number of strokes, your internal combustion engine is classified into 4-stroke engine or 2-stroke engine. Okay. Next one is your components of a spark ignition engine. We are discussed in this slide. What are the components in a spark ignition engine? Okay. First component is your cylinder. Okay. First component is cylinder. It is the main part of the engine where the piston reciprocate. This is your cylinder. This is your cylinder. In this cylinder, the piston reciprocate. Okay. Next components is your cylinder head. The top end of the cylinder is covered by your cylinder head. Okay. You can see here in 2, the cylinder head is here. Okay. The cylinder head is the top end of the cylinder, which is covered by your cylinder head, over which the inlet, exhaust and the spark plug are mounted. In your cylinder head, the inlet, exhaust and spark plugs are mounted. Third one is your piston. It is a cylindrical component fitted inside the cylinder. You can see in this figure the yellow color component. This is your piston. Okay, the piston is a cylindrical component. You can clearly see that piston is a cylindrical component which reciprocate inside the cylinder. Okay, it transmits the force. What is the function of the piston? Now it transmits the force exerted by the burning of air fuel mixture. This piston is to transmit the force which is generated, which is evolved due to the combustion of air fuel mixture inside the cylinder. Okay. To the connecting rod. It transmits the force to the connecting rod. This one is your connecting rod. We'll discuss later. Next one is your piston ring. It is fitted into the slot around the piston. So here you can see, here is the slots. In these slots, the piston rings are fitted. Okay, what is the function? Now it provides the tight seal between the piston and cylinder. Your piston ring provides the tight seal between the piston and cylinder. Next one is your piston pin, always also known as your guardian pin. Okay, piston pin, it connects the piston to the connecting rod. Here is your piston pin in here. Okay, you can see also your 5. Okay, sorry, here is your piston pin. In piston pin connects the connecting rod to the piston. Okay, next one is your connecting rod. Connecting rod, it converts the reciprocating motion of the piston into rotary motion of the crankshaft. Connecting rod is point number 6. This is your connecting rod. Connecting rod, what is the function of connecting rod? Now it converts the reciprocating motion of the piston to the rotary motion of the crankshaft. Okay. Next, crank or crankshaft. What is crank or crankshaft? What is the function? Now, the crankshaft is responsible for the proper operation of the engine and converting a linear motion into the rotary motion. Okay, crank or crankshaft is a 7 number. This is your crank or crankshaft. Okay, it converts the reciprocating motion into the rotary motion. Next one is your inlet and exhaust valve. So inlet and exhaust valve are used to regulate the charge into the cylinder and out to the cylinder. Okay, these two valves, your inlet and exhaust valve, you can see here 8. Inlet valve is your 8A, or exhaust valve is, this is your inlet, this is your exhaust valve. Okay, so this is used for your regulating of the charge. Or what do you mean by charge? Now this is a air fuel mixture. Okay. Next one is your spark plug. Spark plug is here. What is the function of a spark plug? The spark plug, it helps to initiate the combustion process. Spark plug used to help for the initiation of the combustion process. Okay. Now we are going to discuss about your 4-stroke SI engine. four stroke SI means spark ignition engine. Okay, so the cycle of operation is completed in four stroke. In case of why it is mentioned as four stroke, now the cycle of operation is completed in four stroke of the piston and two revolution of the crankshaft. In four stroke SI engine, the cycle of operation is completed in four stroke of the piston and two revolution of your crankshaft. Okay. Second point is there are 5 events to be completed. What are the 5 events? Now these are your suction, compression, combustion, expansion and exhaust. These are the 5 events which which is completed in 4 stroke of the piston or 2 revolution of the crankshaft. Third point is each stroke is 180-degree crankshaft revolution and hence 4 stroke is your 720-degree crankshaft revolution. Okay. Last point is your cycle of operation. What are the cycle of operation? The first one is your suction or intake stroke. Second one is your compression stroke. Third one is your expansion or power stroke. Fourth one is your exhaust stroke. These 4 are your cycle of operation. Okay. So first we will discuss about suction or intake stroke. What is suction or intake stroke? In suction stroke, or the suction stroke starts when the piston is at TDC or top dead center. TDC stands for your top dead center. This one is your top dead center, or this one is your bottom dead center. Top dead center means the maximum level by maximum height the piston can move inside a cylinder. This one is called as your top dead center, or bottom dead center is here. Okay. So in case of your suction stroke, the piston is at TDC, piston is here, piston is at TDC and about to move in downward direction. About to move in downward direction, or about to move into the BDC. Okay. At this time the inlet valve is open. This inlet valve is open. Okay. And the exhaust valve is remain closed. This is the exhaust valve. This is closed at your suction or intake stroke. Okay. Third point is due to the suction created by the motion of the piston towards BDC, the charge consisting of air fuel mixture is drawn into the cylinder. Okay, what happened in your suction stroke? Now when piston starts to move in your BDC, the air fuel mixture is drawn inside the cylinder by the help of your inlet valve. Okay. Next point is when the piston reaches the bottom dead center or BDC, the suction stroke end and the inlet valve is closed. Okay. When the piston reach at the point BDC, at that point of time your inlet valve remain closed and the suction stroke completed. Okay. Next one is compression stroke. Compression stroke. In case of your compression stroke, the charge taken into the cylinder during this compression stroke and it is compressed by the return stroke of the piston. Okay. The charge which is taken inside the cylinder in the suction stroke is compressed in the compression stroke. Okay. Second point is during this stroke the inlet and exhaust valve are in closed position. Or in case of your compression stroke, what happened? Now your inlet and exhaust valves are in closed position. Okay, because the air fuel mixture, if one of these valve is open, then the air fuel mixture can go out by the help of this valve. Okay, so that's why your inlet valve and exhaust valve, these two valves are closed in case of your compression stroke. Okay. Third point is the mixture which fills the entire cylinder volume is now compressed. The mixture, that means the air fuel mixture which is inside the cylinder in your suction stroke, the entire air fuel mixture it get compressed in case of your compression stroke. Okay. Fourth one is your At the end of the compression stroke, the mixture is ignited with the help of your spark plug. After the compression ends, the mixture or the air fuel mixture is ignited with the help of your spark plug, okay, which is located on the top of the cylinder head here, which is located here, okay. Hence, burning takes place instantaneously, okay. Next one is your fifth point. Here, the chemical energy of the fuel is converted into heat energy, okay. Due to the burning, but due to the combustion, the chemical energy which is in the fuel, that is your petrol, is converted into your heat energy due to the combustion, okay, and producing a temperature larger than 2000 degrees centigrade. What is the temperature inside the cylinder? That is up to 2000 degree centigrade, okay. Next one is your expansion or power stroke. In expansion stroke, the high pressure burnt gases force the piston towards the bottom dead center. So your expansion stroke is also known as your power stroke, because in this stroke power is produced, which is help to move the vehicle in forward direction, okay. So the high pressure burnt gases, how the power is produced? Now the high pressure burnt gases force the piston towards the bottom dead center. Second point, during this stroke, the inlet valve and exhaust valve are in closed position. Third point is that the power which is produced during this stroke only, and this is the stroke which produce the work output. That means that from this four stroke, only in this stroke the power is produced, and this is also known as, that's why this is also known as your power stroke, okay. Last point is both the pressure and temperature decreases during the expansion, okay. Next one is your exhaust stroke. In case of your exhaust stroke, at the end of the expansion stroke, the exhaust valve is open and the inlet valve remain closed. The piston start moving from bottom dead center to top dead center. Piston is here in bottom dead center. It starts to move to the upward direction and to the top dead center, okay, and sweeps the burnt gases out from the cylinder. The burnt gases which is produced in the power stroke is swept out by the help of your piston in your exhaust stroke, okay, from the cylinder almost to the atmospheric pressure, okay. Third point is the exhaust valve is closed when the piston reaches to TGC. First, exhaust valve is remain open and the piston sweeps out all the burnt gases through the exhaust valve, and when the piston reaches to the top dead center, at that point of time the exhaust valve is closed, okay. These are the four stroke of your four stroke SI engine, and this is the application of your four stroke SI engine. You can see in the picture in trains and your trucks, your chartered planes and diesel generator. There we are using your four stroke SI engine, okay. Okay student, for the future reference you can go through the NPTEL link, okay. Thank you for the watching.